Now we move on to our second panel and final panel of Powered on Live. We are going to be talking about dealing with renewable energy's intermittency problem. It's quite a big panel, this one. We are joined by Damian Kelly from Innovate UK, Steele from Octopus Energy, Jeremy Yapp from BEAMA, Caroline Bragg from the Association for Decentralised Energy, and Naomi Baker from Energy UK. Welcome all of you. What I will do is I'll go one by one, and I'll give you all an opportunity to introduce yourselves for a minute or two, and then we'll go straight into the crux of the discussion. And so we, just to prevent us all talking over each other, because there's so many of us, if you want to answer a specific question, hand up, and then we'll get to it. So should we start with you, Jeremy?
Okay, yes, thank you. Why not? Thank you very much for having me. My name's Jeremy Yapp. I'm the head of flexible energy systems at BEAMA. BEAMA is the trade association for manufacturers and providers of things and services in the electrotechnical space, which is a fancy way of saying plugs and sockets down one end and huge, enormous, wonderful network infrastructure and pretty much everything in between, except for a few things like lighting and white goods. My focus is on behind the meter flexibility, which is why you've asked me here, and very focused on supporting the market and the technology market.
Have we lost Jeremy? Or is that my internet? Who knows? Can everyone else hear me?
Yes, you're fine.
Yeah, it is Jeremy's internet that we've lost.
He has frozen.
Perfect. Always goes well on Zoom, doesn't it?
He's back.
Jeremy, I think you're back.
I'm so sorry.
We lost you for a second.
So I'm so sorry. As I was talking, I could see Caroline looking very concerned and worried. And that always worries me. So I don't know where I lost you, but I try to support people to use smart tech so they become providers rather than users of flexibility. So in a way that makes behind the meter work better. So yeah, there we go. Hopefully that explains things better. Sorry that you lost me there.
No worries. Thank you so much, Jeremy. Damien, would you like to introduce yourself and where your expertise is?
Will do. Thanks, Jordan. So yeah, morning, everybody. I am Damian Kelly, and I am what's known as an innovation lead at Innovate UK. So as probably, hopefully everybody knows, Innovate UK is the UK's government's innovation agency, and we support and fund innovative businesses right across the board in the UK. I sit in a part of the part of Innovate UK, which is delivering the Prospering from the Energy Revolution programme. So the P4 programme, as an acronym, because it's a bit of a mouthful, is a £102 million government programme to support a range of projects. The sort of core projects are around a concept called Smart Local Energy Systems. So we've got 3 large-scale demonstrator projects and 10 detailed design projects. Developing and designing smart local energy systems right across the UK in towns and cities. And we've got a program of technology projects, funding technology development around mobility and around heat and around energy systems. And we've got a data and digitalization workstream of projects. So we're funding projects looking at data sharing, applications using data and artificial intelligence. And our most recent competition is funding open technology projects, so open hardware, open software. And largely they're focusing on some of the challenges around intermittency and variability of renewables, but wider looking at net zero. How do we get it from a sort of place and distributed energy perspective? And my role within that, basically, I support and oversee some of the projects and some of the businesses, and hopefully design some of the sort of future interventions and support programs as well.
Thank you. Caroline, would you like to introduce yourself and what you do?
Sure. Good morning, everyone. Thank you very much for having me. So I'm Caroline Bragg. I'm Director of Policy and Research at the Association for Decentralised Energy. We're a trade association representing a number of sectors in the decentralised energy area. But I guess for the purposes of this in particular, we represent demand-side response as well as heat decarbonisation. So we spend a lot of work looking at, for example, the market and regulatory reform that we need for a much greater more flexible approach to how we do the electricity system, which I imagine is what we're going to talk about today.
Perfect. And Phil.
Good afternoon, Jordan. Yes, Philip Steele, the Future Technologies Evangelist at Octopus Energy. It's a really fancy title for lots of R&D, tech innovation, experimental stuff. So I've been with Octopus for about nearly 4 years now. Launching things like the Agile Tariff, that's a time use tariff priced every half hour that we're probably already familiar with. And we all worry, why is it hitting its 35 pence cap with the wholesale market crisis? But it is a super engaging tariff for the tech enthusiasts, that's the polite word, that really want to engage with how energy is generated, how the grid works, and how better to consume it. But then obviously we're doing all sorts of things with heat pumps and EV chargers, selling cars, investing in renewable generation, and making all sorts of smart tech work to make all that balance and work together effectively. That's me.
Perfect. And last but by no means least, Naomi.
Hello, I'm Naomi Baker. I'm a Senior Policy Manager at Energy UK. Energy UK is another energy trade body. What's different about us is that we focus on the whole of the market. So we represent, I think, around 95% of retailers now, 80% of generators, and an increasing number of our members come from sort of the new energy space. So heat, electric vehicles, and flexibility. I work on across that heat, flexibility, and electric vehicle space. Thanks.
Perfect. So we're going to get on to the main question of the panel, which is with the grid increasingly moving to renewable generation, what can be done to ensure the inherent issue of intermittency is dealt with? Who wants to start? No one? Don't all go at once. There you go, Caroline.
Well, I guess I think one of the kind of useful ways that I find to sort of structure this type of discussion is to think about it in terms of perhaps different timescales, because the kind of challenge that you're dealing with and the kind of opportunities and the response that you want to put towards that are different for different types of timescale and what you're trying to do. So that might go all the way from sort of sub-second kind of needs of the grid. So as we get more and more renewable generation, the other kind of real characteristic that they have, alongside being variable, is that they tend to be asynchronous. Whereas previously, lots of what we had on the grid in terms of gas generation, for example, nuclear, coal, is spinning masses that are synchronously connected. So inertia is a big part of how you operate a decarbonised system, and we'll have to find new approaches to that. So that takes you from the kind of one extreme. I think then you have to go through intraday and how we balance the system hour by hour, half hour by half hour, into the kind of day ahead, and then actually all the way to on a seasonal basis, and then in terms of having the capacity adequacy that we need over years. And I think the kind of opportunities that we have are quite different, actually, and really interesting when you look at those different timescales. We might say, for example, that very fast acting battery storage, for example, which will include, for example, also EV charge points, as well as perhaps more exotic things. So flywheels, for example, might be the answer on the sub-second side of things, but actually the way in which we meet capacity and meet the need for very large amounts of kind of demand and storage flex over interseasonal period is actually quite different, and we'll need kind of different technologies, a different approach.
Could I
hear me? Yeah.
Oh, sorry, Naomi, I don't want to speak.
No, you go.
I just wanted to take a step back away from some of that detail and say, as a very rough rule of thumb, an old way of managing the energy system was to forecast demand and manage generation to meet that. So you know that everyone's going to turn their kettles on when the UK has just won a silver medal or just won the World Cup or whatever. So you know that's going to happen, so you get ready for it. The new way of managing the energy system is to forecast generation and manage demand in response to that. And that's a very, very rough rule of thumb. And of course, there are exceptions and there are lots of very interesting details, as Caroline's just set out, in more detail than I could. But I think just if we get this basic sense that this is the revolution we are in, this is what's happening to the energy system, it's becoming responsive to generation rather than responsive to changing demand.
Naomi, you had something you wanted to say.
Yes, I think this complements the other transfers quite well. So I'm going to zoom out a bit further and almost look at what's the challenge. I think the first thing to do is recognize the challenge and recognize that what we're actually looking to do is a complete sort of change management system almost. The grid that we have is built for a power sector that doesn't exist now and certainly isn't what we're going to be, what we're going to have in 2030. So recognize it is whole scale change and therefore respond accordingly. The system operator produced a really nice report earlier this year called Bridging the Gap, a flexibility report, where it broke down how do we handle this challenge into 5 themes. So the first was investment, recognize the scale of the challenge. What investment do we need? Do we need to start investing in those very different systems now? Markets, so both the incremental change to the existing markets and also what new markets do we need to empower this new infrastructure and this new system that we're having? Consumers, the report really highlighted how key consumers and consumer demand and demand side response and active consumers will be to this new system. Digitalization, Laura Sands from the Energy and Digitalization Task Force has a really nice analogy that she often uses here about how the kind of change that we're about to undergo is effectively going from a very small, close-knit system where the people working in it know each other's health handicaps and a very small number of systems on the grid, to one where we've got millions of different interconnected, distributed systems. So that's, that I think that to me really underlines how important digitalization is. It's not a system where you can have people making individual decisions in a control room anymore. It does need to be digitalized and automated with artificial intelligence running through that system and empowering it. And then the last theme is roles and responsibility. The governance that we have at the moment is suited to the old system. But say the roles of Ofgem, there needs to be a lot of clarification around what is the role of Ofgem, particularly in new areas such as heat. The regulated monopolies, for example, what is the role of those actors in terms of how we're going to change the system and some of the new services that the system operator needs. There's definitely a sense that there are overlapping responsibilities and also that there's a lack of strategic oversight in terms of looking at where the risks are and some of the opportunities are. So I'd say those 5 sort of themes: investment, markets, consumers, digitalization, roles and responsibility.
Does anyone else?
Yes, Jordan, actually, we're all going to the other level. Let me go right down to the other end of the scale. I'm going to talk about what the customer experience is, because you can look at it as Caroline and others have talked about there, the whole system level side of things. But actually, what we really like doing is engaging customers in how the grid works in renewable energy. I mentioned Agile. There's not a massive number of customers that are on Agile, but they are the super engaged that really get what's going on and want to kind of take part in it. So I'm going to just share my screen because I noticed the screen sharing is active and I can do this. Yeah. Okay. So one of the tariffs we've launched is the Fan Club Tariff. So this is customers that live near one of our wind generators. There's only 2 that we've done this with so far, and they get a 20% or 50% discount from their generation from that local wind generator. But of course, it's interesting. I went and spoke to a bunch of customers at one of these wind generators, and they were asking about the data. And there is a dashboard that we give them access to, and they said, "Do you fake the data?" I said, "No, it's real data. We are getting 30-second data from these wind generators, and we make it available to customers. And this is what they can see. Fortunately, it's a sunny day, not a windy day. So we haven't got a lot of data that we can see, but this is what Fan Club customers can see. So where am I at the moment? Which one's this? This is in Wales, Steffenbach, South Wales. So the wind speed is 2.6 meters. So we're not into the 20% discount band at the moment. That's the real rotation. If you stood and watched it, that's what it's actually doing right now. And unfortunately, it's consuming electricity just to keep itself ticking over. Every now and then, this is just picking up. If we watch, we might see 10 or 12 kilowatts come out of it. There you go. The rotation is 1.6 revolutions a minute. It's going very, very slowly. But it's engaging customers in that renewable energy and saying, when there is a lot of wind on here, we're up at that kind of 10.8 is the mark, actually, you're going to get your discount. And then they're going to do extra things. They're going to charge their car. They're going to run the dishwasher and the washing machine and all the rest of it. I think the Yorkshire one. Oh, the Yorkshire one's a bit better. 3.6, nearly 12 revolutions a minute. We've got a couple of kilowatts of generation off that one. But that's the other
observation about this, Phil. I think this is fascinating, and for me, this encapsulates the paradox of the smart technology and the journey that we as a country have been on for the last 10 or 15 years. So smart metering was going to be this, and still is, and I absolutely believe it is, the gateway to engaging consumers in thinking about their energy for more than what is it, 7 minutes a year or whatever the statistic I've heard. And that's what smart meters were going to do. And I think it has succeeded in many, the other thing that succeeded in making people think about their energy is price rises, but let's put that to one side for a moment. A decade ago, people didn't really think very much about where their electricity or their gas came from. They didn't much care. Unless you were on something like Economy 7, you probably rarely gave it a thought. And what the smart metering program was going to do, and has done, is engage people in their energy use in really interesting, powerful ways that would lead early adopters or informed people to take up a tariff like you've just described. And when you say you've done this with two, I presume that's 2 wind turbines, not 2 customers.
2 wind
turbines. Yeah, cool. So here's the paradox, is a lot of that stuff absolutely is right there to engage people. But what we also need are solutions that allow buildings, domestic buildings, to provide demand-side response, to use demand-side response to provide flexibility from behind the grid, even over long time periods, as Caroline was talking about before, with the consumers themselves knowing nothing about it because they're too busy. So we've got this wonderful paradox where, yes, we want to engage people with energy and smart technology, but we also want to make sure that people can engage in this market, play with in these markets, having it all automated and invisible to them. And I think that's a fascinating challenge.
Naomi, I saw your hand up there.
Just to come in really quickly with a small point, I think those two things are completely compatible. I think people do want things automated, but they like to see what's going on at the same time so they can be engaged without having to do any of the work. Similar to Phil, your point, my dad is completely obsessed with the National Grid ESCO app. Mm-hmm. He's completely obsessed with it. He keeps sending me, people love this stuff. I don't think he wants to do any more than that, but he does enjoy looking at it.
No, there's some brilliant apps around this. There's ones which show you the whole grid makeup. The carbonintensity.org.uk, that's another one. There's one that's got all the maps of nuclear generation, gas generation, solar generation, wind generation, and forecasted or planned renewable generation as well. There's a lot of data around. It's really engaging.
I don't need to tell you, but there's so many people doing different things with the Agile API. So people are really getting interested. We just had an audience comment where they were just like, I'm looking at my smart meter always and switching things off as much as possible. So people are engaging more.
They are. I mean, I guess I think part of this, though, isn't it, is that whilst Octopus is doing amazing things, and there are a couple of companies who perhaps are also, looking kind of very seriously at time of use tariffs. I think where we need to be is, there's a lot of money to be made out of those time of use tariffs, and many more companies are doing them. We're still at a very nascent point where, the kind of the structure that sits behind the kind of wholesale market, etc., that sits behind those tariffs is not pushing the market as hard as it should be at the minute. And I think that's one of the big things that we need to figure out, particularly given that we are about to embark on some quite serious reforms to that market and others.
I do like, Naomi, your point about that kind of the automation, because that's the more mass kind of group of customers than the super engaged, but the visibility of the data. So the intelligent Octopus tariff takes that to that kind of level. You set your car to charge to 70% by 6 a.m. and overnight we'll take the best half hours, and then you can see all the data. And then we may charge it outside of the intelligent Octopus time period of half midnight till 5:30 when you get the equivalent go rate of 7.5 pence. And then your whole home gets that lower rate in the peak period on that tariff as well. So that kind of is where we switch over from you've got to do something, you've got to program stuff against the API, you've got to watch the data, to actually it's automated, but you've still got full access to the data. The Fan Club Tariff was just showing we are in the process of hooking it up to an online service called If This Then That, if anybody's played with that. Again, that's kind of the very technical audience, but it's another way of saying, I want to connect this data to something else rather than continually having to watch that data.
Damien, I believe I saw your hand up.
Yeah, I was just going to come in on the point, I think, around sort of data and digitalization. I think both Caroline and Phil were sort of touching upon, and I think Caroline touched upon that, Octopus are at one end of the scale from many aspects around data digitalization. It's from the outside, certainly appears to be a sort of digital native organization, but we're very much not in, that's not the situation right across energy. So we've been involved with Ofgem and BEIS in sponsoring the Energy Data Task Force and the Energy Digitalization Task Force over the last couple of years, which I think Naomi mentioned there recently. And I think it is vitally important that we do focus on some of the really basics that probably an organization like Octopus have as a default, but there's some really important things we need to focus on. And one which I think Ofgem in particular have been focusing on over the last couple of years is around energy networks and opening up their data and the sort of benefit towards, particularly around innovation around sort of net zero and integrating renewables to opening up energy network data. And I think that's been a really positive step over the last year or so. And we've seen some of our projects in particular have benefited and are, I'd say, pushing the networks to adopt that presumed open approach. And there's a long way to go. But yeah, I think the point is sort of trying to make is there is a lot to do, and it's fundamentally important that we get those data digitalization fundamentals in place so we can see more octopuses right across the system.
Jeremy, you had your hand up first, and then I'll go to you, Naomi.
I absolutely don't want to derail the conversation about open energy data because I'm fascinated by it. I just wanted to take one step back, just quickly, if I may. So in 2 weeks and 12 hours and 1 minute, it will become illegal to sell a charge point in this country that is not smart, unless you have an agreement with the government to do so. This is for domestic charging. And that's terrific, except where are all the smart tariffs that those people who are using a smart charge point can use? So without wanting to put you on the spot, Naomi, when are your members going to start providing a market full of smart tariffs rather than just a few? You don't actually have to answer that. I'm just...
This is probably more a question for Phil, but in terms of our members, there's a missing money problem at the moment with time of use tariffs. So suppliers are, and again, Phil is much better equipped to talk about this, suppliers are losing money on them at the moment. So until the basic proposition stacks up, suppliers won't offer it, particularly in the constrained market that we have at the moment, where I think we saw 40 retailers go under last year. So we do need changes to the system to make that work for retailers and for them to become more attractive. I've got another point, but shall I hand over to you, Phil?
No, you're exactly right. Not every customer is loss making at all at the same time, but it depends on when a customer joined and which tariff we put them on and how far out we hedge their energy. I don't have the details on all of that side of things.
I'm still on the old Octopus Go, so I still got like 4.5p. So it's just anecdotally.
I know.
I'm quite lucky.
I feel slightly lucky and slightly guilty because I'm on a Go Faster version that's due to expire in August, and then I'm looking at the dates and going, I'm going to have to renew on the next version of the tariff. But, it is very difficult for energy suppliers to introduce a new time of use tariff right now because of the wholesale market.
Can I ask on that? As well, because one of the things I think that at least I've heard is also problematic is the extent to which Ofgem is effectively now managing suppliers' hedging strategies effectively by proxy because of the requirements around the price cap. In terms of how that develops over time and where you think the price cap goes in relation to trying to get to this much smarter system where time of use tariffs are a more kind of normal part of offerings by suppliers. Do you think we need bigger reform there?
No, I'm not sure. It's not my area of expertise on the tariff and pricing. That's a psycho Clem type of question. There are reforms needed, like the green taxes that are on electricity rather than on gas and so on. The electricity market is driven by the gas wholesale prices, and yet, actually, I was looking at the data yesterday. We were at over a quarter of our energy was being generated by solar yesterday because of these beautiful sunny days that we've got right now. That's actually a marginal cost of zero. And yet, for some reason, it's unprofitable to supply customers. There's something weird about the market, right?
One of our audience members said there is a danger of confirmation bias here. We all like data. We all like... We all are in the industry. Well, you guys are all in the industry. I'm more writing about the industry. But 99% of the people out there may not be as interested as we are. So how do we deal with that problem?
So I think that's exactly the paradox I was describing, and that Naomi resolved, if you like, which is that you obviously you're engaging. I'll let Naomi take over in a moment, perhaps. But obviously you can engage people more with this new technology, and as prices go up, people become more engaged. But the point is, by rolling out this technology and by developing these new technology that enables tariffs that are all enabled by the sorts of market changes that Caroline was talking about, what that does is it allows people to engage with the energy market and not have to think about it, because it becomes automated. And that is the absolutely key word here, automation. So you set your parameters, you say what you want, you describe it in as much detail as you want, and then those artificially intelligent machine learning systems do it for you, and you retain control, but you aren't bothered by it. And I think the word that we're all talking about here is empowerment.
Good example. Oh, Caroline's got... Sorry, Caroline. Can I, Caroline?
Yeah, go on, Phil. Yeah, of course.
I'm not polite enough to put my hand up. A good example is Together Housing, social housing provider up in Lancashire. So over the last couple of years, they got some European funding to put solar battery systems onto 250 homes. Because that was funded, those tenants got the solar energy for free. But now they're now looking at how the investment portfolio across, there's something like 40,000 homes that they own up in that area, how they can put more of those systems on large numbers of homes. That gives free energy or certainly much discounted energy to the tenants of those properties, and it allows, because they're putting batteries in, that system could be participating in balancing the grid locally and so on as well. That's really interesting, because that's using the technology for the kind of homes that would benefit the most from getting prices down.
I think the only thing I wanted to add briefly.
I'm going to. Then we'll go to you, Damien.
Come in, yeah, exactly. No, putting up my head. No, I was thinking, the only nuance, I guess, with that from what we see as well is I need to look at the most up-to-date ones, but certainly a couple of years ago, we were still at a point when you look at, say, base statistics on public awareness around the energy transition, where less than half, so about 45% only of people knew that carbon emissions come from boilers, for example, and that heating is a major source of greenhouse gas emissions. So I think I totally agree with everything that's being said, but I think as you move to on heat decarb, I think there is still this enormous piece of public engagement that we still just haven't got to grips with yet, in a way that perhaps doesn't now pertain quite as much to the electricity system. I think people are slightly more aware of what's going on. I think with that, there's an interesting thing that's happening in Scotland at the minute, where they are establishing a national energy agency, and one of their mandate might well include public campaigns around what needs to happen next on the transition, which I think is really quite positive. And it would be good to see something similar, particularly in England. Sorry, good. Damien, go on.
Damien, yeah.
That's all right. I was just going to pick up on a couple of points Phil was making. And I think in relation to the sort of general topic, I think, the challenges and opportunities around variable renewables are many. And I think one that I think Phil touched upon in a couple of points was the challenge of abundance and the opportunity of abundance. And how do we actually really how do we set the rules and the market structures and whatnot to take advantage of energy when it is abundant and when it is zero marginal cost? One of the really interesting projects we have up in Orkney is looking at that challenge and looking at that challenge in real life, and it is very much a challenge at the moment. How do you actually take advantage of that zero marginal cost energy? Because at the moment we don't have the market structures and the rules in place to do that. So Orkney is, a fascinating place for innovation. It produces well over 100% of its annual power needs, and it's got like a finite connection to the mainland. So you've got what's called the angriest active network management system in the country up in Orkney. But what we have seen through the project is, I suppose, those use cases or that value to people like social housing tenants, where they could have funded solar and storage installed. But under current rules, that's actually not possible because of active network management rules and how we're curtailing energy. And we could spend a whole load of time on A&M and curtailment, and active network management in itself as a technology has done a load to increase the amount of renewables coming onto the system. But we now need to be looking at how do we use that zero marginal cost energy, and how do we use it to provide value into people who at the moment are very stretched as regards to bills, because at the moment the rules basically don't really enable us to properly use that zero cost energy.
Yeah, and I think there's an interesting project, isn't there, that's happening that might have a bit of potential on that around a local constraint market, which the ESO is developing, particularly because the way that the transmission network is developed at the minute, obviously we've got a lot of wind in Scotland and we don't have very many cables to get it down to England, where there's much larger sources of demand. And whilst you could be doing that through the balancing mechanism, the way that the ESO's IT infrastructure works and all sorts of things means that that's not working as optimally as we'd like, actually. And I think the beauty of this market potentially is that what it will be doing is effectively targeting flexible demand and storage that's effectively in kind of the lowlands of Scotland, kind of south of Glasgow and Edinburgh, specifically to see whether they can do turn up when we have excess wind, but with a market that is much better designed towards reaching smaller scale distribution level assets. So it'd be really interesting to see what comes of that, I think.
And just actually on Caroline's point, if I could just make a quick highlight the Strategic Innovation Fund to people. So the Strategic Innovation Fund is the sort of follow-on or the revised network innovation competition. So that 2 of the 4 challenges in the 2023 Strategic Innovation Fund are exactly around some of those use cases I think that Caroline was mentioning, but pretty much around how do we actually provide novel solutions towards enabling a fully renewable, fully zero carbon, largely variable renewable backed system. So yeah, if anybody's any innovators out there are looking to collaborate with networks or the ESO and whatnot, do look out for the 2023 CIF. Some of the challenges are there at the moment, and applications are open from September.
I will jump off that point, and regarding energy storage is what I want to talk about. Basically, like you said about we're going to need more zero carbon, and if we are going to go with mostly renewables, will we need more energy storage, or is it good to have their like a base load such as nuclear to be there as a base load to help the grid going forward? Someone in our audience actually asked, are we over-relying on lithium-ion batteries going forward?
And I think one part that's important as part of this discussion is if you look, for example, at where we were during COVID, what we saw during COVID was an enormous fall in demand at a national level. And that situation may not be dissimilar to where we might be going forward at different periods of time, depending on how much decentralized electricity generation we get, which obviously suppresses what you see at a national level in terms of demand. I think what's interesting with that is that I think really for almost the first time in anger, as it were, we got to a point where National Grid was struggling to turn off enough at transmission level. So they were issuing, they have a horrible acronym, but very shrill notices basically to say we can't turn off enough at transmission, given the levels that are so low now for demand. And I think what's important with that, when we start to have this discussion about nuclear, and particularly in the context of government targets on this, is that nuclear is not able to really ramp in a normal market fashion. It doesn't participate in the balancing mechanism that much, which is the normal way that we would ramp down transmission generation. And during the course of COVID, the ESO actually had to sign a confidential agreement with Sizewell for it to turn down during that period. So I think it's really actually quite important that we understand this in terms of quite strategic operability challenges that we are likely to have between transmission and distribution, and how nuclear, particularly very large amounts of nuclear, is going to be able to flex or not in a market-based way to that.
Jordan.
Yes.
Your question there was, sorry, you finished, Cara. Your question there was related to storage as well, and lithium-ion batteries. And I find that really interesting because the moment anybody hears storage, we all immediately think of batteries because they're all in an electricity mindset. But there are lots of ways of storing energy. So if lithium-ion batteries, okay, so that's home storage and cars. So those are the two, and maybe grid scale battery systems. There are other grid scale systems. VFRBs, that's an interesting one. Vanadium reflow batteries. I've seen the fourth largest in the UK, and it's the only privately owned one, and it works, and it's brilliant. But also, if you look at, say, a heat pump is actually an energy generator. We all think of it as just a heating system and therefore it consumes energy. It does, but it's actually generating energy. You put a kilowatt hour of energy in, you get 2.5 to 5 times the energy out of it. So it can be a store because you can use that to store hot water, as well as to some extent a thermal load in a property. There are other, I think we discussed at the beginning of the session, some of the other storage things like gravity wheels, cranes lifting big blocks of concrete up and down, water pressure, air pressure, Cheesecake Energy, they do an air pressure system. So those have all got different kind of durations of storage. So we shouldn't just kind of fix in our mind that it is an electrical battery. I'm going to put in the chat actually an article I wrote back in April because I spoke about some of this at the Fully Charged event earlier in the year. It was a cold day, so the picture shows me in a hoodie feeling quite cold. It's a very different day from today. But there I've written about got quite a bit about different storage technologies and things. So if anybody has any feedback on that, shout.
So I love the formulation that you've made about heat pumps. And one of the things I love about heat pumps that they don't create heat, they move heat. And I just think, even though obviously we're talking about such small levels, we're not talking about global heating, it's just nice to heat one's home with something that moves the heat from outside rather than makes more. Further to your point about storage, could we please have a moratorium on removing the hot water tanks from buildings? Could we please make that like illegal beyond can we put that off the scale? It's very, very important that we as a country maintain and increase our stock of thermal storage, because it is actually quite manageable. It's quite dispatchable. It's not quite as quick as a battery, but it's very good. And it's an absolutely essential part of this going forward. So I hope we can make sure that all new homes have them and that we don't get rid of any more.
Naomi.
I definitely agree with that. I'm really like your emphasis, Phil, on the different durations of storage that we need. We need this whole sort of all the tools in the toolbox. And I think nuclear and storage have different roles, particularly. I don't think it's an either or. But I think around this whole discussion, there's a real question about, there's lots of interesting innovation. There's lots of really good work going on across the sector. But there is a question about whether it's happening at the scale and pace that we need. If we look at the increased generation that was announced in the energy security strategy back in April, one of our members, LCP, did some analysis on it, and they estimate that if we get that 50 gigawatts of wind, the 5-fold increase in solar, I think it is, all on the grid by 2030, that it will mean that for about over 50% of the year we'll have excess generation. That completely changes the game for what we're talking about in terms of the scale of storage that we need. So I think we need to be looking much more seriously at how we have a financing mechanism for some of the more innovative or else expensive long duration storage. For example, pumped hydro. I know the government was looking into a sort of cap and trade scheme, wasn't it? Karen probably help me here. Cap and floor system scheme to help with long duration storage. So given how long, say, pumped hydro takes to build, it's something that we need to be thinking about now if we're going to have that very different system by 2030.
Another point I really wanted to make was we touched on it a bit earlier regarding whether or not reducing how much people consume. Like we talked a little bit about moving, electric vehicle charging to the nighttime using time of use tariffs, but we also need to reduce how much electricity people actually use. And recently in the energy security strategy, there was nothing to do with energy efficiency in there. Was that a mistake?
It was an absolutely appalling dereliction of duty. It was a dreadful mistake. It ought to have been there. These things, I'm normally a fan of asking government to do one thing at a time. And if, for example, if you want to reduce air pollution in London, don't do it through a congestion charge. Do it through something that will actually target air pollution. However, in this case, energy security and energy efficiency are so tightly bound that, yes, I have you can probably tell, I have quite strong feelings about this. So, yes, it was a mistake. I should say, actually, just to your point, Jordan, electricity use is going to go up. And 100%. That's good. That's like that, rightly so. We want people to use energy more efficiently, more effectively. We want people to use less energy, but we do want people to use more electricity. So I am very much of the persuasion that you look around you, electrify everything you can, and then look around again and electrify that.
Yeah. And that's the thing, like the point that I was trying to make was in terms of like, if we are going to go on this upward curve, you don't want it to be so upward that people are wasting energy. You want it to be, a gradual upwards, that the increased energy, like electrification, like heat and transport is going up, but we're using energy elsewhere more efficiently through smart home technology.
If you had very, very efficient homes, then the seasonality of electricity use would also be reduced, because you would be spending the difference between your energy use in winter and summer would be less. And that addresses part of the point that Naomi made with the LCP report.
I think as well with that, I think we have to understand the scale of the challenge in doing that, particularly in the context of where energy efficiency programs and that supply chain is now. We represent energy efficiency installers who have seen, the Green Homes Grant come and then immediately go. They saw the Green New Deal come, go, and they've seen a persistent lack of any concerted push from government to meet its own targets to retrofit homes to a decent EPC level. And I think more than that as well, I think there is a kind of constant lack of understanding how energy efficiency can be really part of the kind of the DNA of how we structure markets in the UK. So we, just as Jeremy was saying, when we look at what do we need in the next few years, for example, in terms of meeting demand, energy efficiency is not part of that in any real way. We look at demand as if it's just going to do its thing, and then we kind of try to meet it with new generation, which is not the way that other countries have done it. Other countries are able to integrate energy efficiency considerations better than we are at the minute.
Completely agree with that. There was a story in the Times today, actually was quite interesting, that that Number 10 is interested in putting 1 billion into the Eco Energy Efficiency Programme. So, I mean, if that does happen, obviously that's very positive. But going back to what Caroline said, it is all about the supply chain. And we know that the reason why the Green Homes Grant failed was because the supply chain couldn't suddenly ramp up in sort of 6 months.
Oh, controversial. Do we know that? I'm not sure we do know that.
As the representative for the electrical supply chain, I would like to.
Okay, so we'll rephrase it. So the market was 0.7 billion a year, and then 2 billion was put into it. So I think it's quite a hard ramp up for any supply chain to do that. So the members that we speak to, so they absolutely can scale up and do a much bigger program, but what they need is certainty. So they need a multi-year program so that because labour is very tight at the moment. So if they're getting more people on board, they need to know that it's going to last for more than 1 year or more than 6 months in the case of the Green Homes Grant. So the message that we consistently get from retailers delivering eco, for example, is that, yeah, we can absolutely scale up, but we need a multi-year commitment. We need to know what we're doing, because otherwise we can't get the labour.
Exactly. I mean, just to add on that, I think the other really poor thing that happened with the Green Homes Grant was that ICF, who were the sort of outsourced contractor brought in to manage that scheme, it was extraordinarily slow in putting forward the terms and conditions, which if you are an SME installer, you can't be dealing with that level of cash flow risk. Is what we found, and it took a great deal of time to get them up and running. Well into, I think it was 6 months into the scheme when we were trying to do it. We had people who were running enormous levels of cash flow risk so that they could participate, which I think was a really that was a very significant reason why it was not successful too.
I guess the really interesting thing about that program was that there was high demand. There was really high demand, and that often gets lost in some of the coverage of it. It's viewed as a failure, as actually it did demonstrate that demand is high.
Exactly. And we've still got the local authority delivery part of that, right? Which is going blazes.
Jeremy.
People are desperate to improve their homes. They are desperate to improve the energy efficiency of their homes. They want to buy energy efficient homes now more than ever. It's so important that we find some cost-effective ways to give consumers what they want here. Just a little bit of ancient history. I was working in DEC about 10 or 12 years ago, and I remember the ashen faces in the corridors when it was announced that the interest rate for the Green Deal would not be competitive with the sort of loan that you could get from your lender. So it had always intended to be a very competitive rate. So the Green Deal was, I will borrow money cheaper than market rates in order to make improvements to my home, to make it more energy efficient, to make it more sustainable, to electrify, etc. And when that became not competitive, and suddenly we had, was it 27 people took up the Green Deal or something, and we had been expecting hundreds of thousands, it was an absolute disaster. So we shouldn't interpret those failures as a lack of interest from the public. We should interpret those failures as poorly designed policy.
One of the major criticisms we had from our contributors was what was briefed by the government originally with the Green Homes Grant wasn't what ended up being the actual scheme. So the government briefed that lighting was going to be part of an energy efficiency improvement that everyone in the lighting industry will tell you is a massive energy efficient improvement that every household can make relatively cheaply, relatively easily. And then when the actual Green Homes Grant fully launched, it was that there's no lighting covered. Was that a mistake?
I think the main mistake was also just purely overcomplicating it.
Yeah.
Right. I feel a little bit like we were involved in discussions when it, was sort of getting off the ground, and you could already tell the level of funding that they had to get out of the door. They should have chosen the absolute simplest way of doing that, which in our view, in all honesty, would have been just to throw it into eco, which we've been doing for many years now. We all know how it works. It's a very settled, established scheme. But this kind of, just this level of kind of civil servant micromanagement of that scheme, because they were worried about the levels of money involved, et cetera, et cetera. It's just, that wasn't useful. They should have gone for, we know how eco works. Everyone knows the rules of the game when it comes to eco. I think it would have been a much more successful scheme.
It was a Treasury jobs creation scheme, wasn't it, initially? Yeah. And then it sort of turned into something else. So I think it's that conflict, which is where was the issue, really.
Damien.
I was just going to make the point that, I think we're probably all singing from the same hymn sheet on the call, and energy efficiency needs to be, it needs to underpin what we do, going forwards as regards to achieving net zero. And we need sort of stable, consistent policy and sort of routes to market, et cetera. Because what we have seen and what everybody's been talking about is sort of boom and bust and sort of flip-flopping as regards to where the programs sit and where the support sits. But we really do need now to give everybody a bit of sort of predictability and certainty as much as possible to really activate and stimulate the market. And because it should and needs to underpin what we do over the next 10, 20 years.
Definitely.
I know that we are slightly over time, but there are two questions that I want to end with. One is from our audience, from Ison, who said, "Thank you, Phil, for the paper. For someone that is quite keen on battery storage, I wonder if the panelists can share their views if battery degradation issue has been considered in depth as grid storage. I read that industries are looking at repurposing EV batteries."
Good question. Kind of related to that, actually. Claire Miller, who looks after innovation in our electric vehicle business. If you look up her, she talks a lot about the power loop trial that we ran, where we are charging and discharging cars rather than just charging them. So vehicle to grid using wallbox charger. And in her analysis of the 130 odd cars that we've got out there, we've actually been treating the batteries better. They're performing better because we are it's a steady discharge and a steady charge than if that battery is in a car and its discharge is ramping up and down as you're driving and braking and all the rest of it. And the batteries actually may be performing better in a vehicle to grid kind of scenario. That would if I extrapolate that a little bit, if you get to reuse electric vehicle batteries for grid storage, you're probably going to get quite a bit of lifetime out of them rather than run risks that you've got a half depleted battery, a damaged battery, if you like, that may not have issues in the future. But then there are other technologies as well on grid storage, like the VFRB, the vanadium refi battery. That is new technology, but it's kind of proving itself. It's got a different level of scalability because you just add the extra anode cathode modules to it, or you expand the tank of fluid that's in there as it pumps fluid from one side to the other through the membrane. So it's got a kind of different method of expansion of kilowatt hours capacity or kilowatts capability, but it hasn't proven its lifetime yet. As a chemical battery, it probably will. Go on, Damien.
I was just going to flag a project that myself and Caroline were lucky enough to get to see in the last couple of months, which is the Pivot Power's hybrid battery system as part of their Energy Super Hub Oxford project. So they've got I think it's about 50 megawatts in total, about 48 megawatts of lithium ion and a couple of megawatts of vanadium flow. And they're very much the use case they're looking at is around degradation. So how do they maximize the value of their total asset with the different grid services they're providing by using the benefits of the two different technologies? So yeah, that's definitely one to investigate a bit more. The flow battery element is just going live at the moment. So I think there'll be some interesting research coming out of that over the next year.
And I have a final question, which is, in a switch to renewables, interconnectors could play a larger role in the grid going forward. The UK currently has 7 operational electricity interconnectors, which are far fewer than many other countries who can rely on renewable energy generated elsewhere. The UK government wants to more than double existing interconnector capacity by 2030, but will this be enough? And is work on these new interconnectors happening fast enough? You want to stay that on?
I'm just a humble behind the meter guy, Jordan. I can't answer that. So BEAMA has a network sector. I don't run it. So I'd like to run it one day, but I don't run it now. So I can't give you an answer to that. But I would say if there are concerns, then that's got to be treated as an infrastructure problem, as an infrastructure challenge. So yes, let's look at that. Let's talk to the ENA. Let's say, what are your forecasts? And let's make sure that the physical infrastructure is there. And also, can I just say, in the right place? So we do sometimes over at BEAMA feel like some of these decisions are being made without talking to the physical infrastructure providers. So we need to make sure that the energy data that we've got is being used to inform those decisions properly. That's a slightly waffly, non-committal answer. I don't have a yes or no. Others may have a Damien. Yeah.
Well, I was going to suggest we could possibly pick on Phil, because I think the Octopus potential proposal around the sort of Morocco-based large-scale solar, and whilst it doesn't look like it's technically an interconnector like most of them are now, I mean the general principles are the same around diversifying generation from far away or different shores. So, Bill.
Yeah, no, I was going to bring up Morocco. I mean, it's the obvious one. There's a gigantic solar array that's being built with a couple of very large cables back to the UK. So I think it's supposed to be capable of supplying 7% of the UK or something at its peak. There is a battery included, because if you've got really large cables from a solar field, you're going to have to cope with the peak at the middle of the day, and then it's kind of idle through the night. So there's a battery being built alongside that as well. So that will bring the peak down and push energy through the rest of the time of day as well. So it's trying to balance that. It makes the cable connection a lot more efficient in its scale and capability. So that's a good example. As to other interconnections to the rest of the continents or other parts of the world, I haven't got an opinion, I'm afraid.
The only final thing, I think there is an interesting question, perhaps on the market and the system side of this, which is that interconnectors are just cables. At the end of the day, their usefulness is the generation that they're connecting to. And I think at the minute, at least in the UK, we are fudging that a little bit. So interconnectors play as effectively generation in the capacity market, for example. And we do that in terms of broader adequacy requirements. What you really want to get to, I think, is a way in which the generation that's sat at the end of that interconnector is properly part and integrated into the markets that we have in GB. And indeed, actually, when very awkwardly the UK government was successfully sued for its capacity market a couple of years ago, that's precisely the condition that the EU set them. to try to figure that out, because obviously when you look, it's one thing for the UK versus Europe, but on a European basis as well, we need to have a much better understanding of what generation is promised where, particularly if you're getting into a situation where it's even more important and you might be getting into kind of scarce capacity at some points. But I think the UK government took the advantage of it is a Brexit opportunity to not have to figure that out. So that remains an outstanding question currently.
I'd agree. I think more interconnectors make sense with the kind of scale of generation that the government are looking at. But as Caroline said, it needs to be a level playing field with other forms of generation.
Thank you. And that is, unfortunately, all we really have time for. I know we're 15 minutes over and we've taken up a lot of your time. Thank you all so much for being here. Is there anything anyone else wants to say finally?
No, pleasure to take part.
No. Perfect. Thank you so much for joining us, everyone. Have a great rest of your day.
Thank you. Bye-bye.
Thank you, Jordan.
Bye.
Thank you all.